Today I'm introducing the speakers. We've got Kim Carter from BinaryMist today, who's going to talk about developer productivity. It's a subject close to many people's hearts, which is why it's good the room's full. So I'll hand you over to Kim, and he'll take it away. Thanks for your patience.
So basic talk is on increasing productivity, developer productivity. I thought this slide was a bit of a laugh, so this quote was a bit of a laugh, so I just added it in for giggles. So yeah, I've lost my notes, so I'm going to be basically going off a tablet, so excuse me for a bit of disorganisation there. So emphasising quality at the end of your project, and you emphasise system testing. Emphasise quality in the middle of your project, and you're emphasising construction practices. Emphasising quality at the beginning of your project, and you're planning for, requiring and designing a high quality product. And it's all about detecting errors at the stage that's the least time consuming and the cheapest place to correct them. It's going to work, yep. So yeah, essentially bringing the quality focus up front. So this chart here just shows basically a time that your defects are introduced versus the time that when they're detected, and the cost differences. This is taken from Code Complete. So as you can see, if you detect a defect in your post-release stage, and it's a requirements defect, it's going to cost you 10 to 100 times the price to fix it, as opposed to finding it in the requirement stage. And this image here basically just shows you the same thing, but it's a bit more visual, sort of gives a bit more impact to the situation. And this image here is an image from Scott Embler. I've used it a few times. It really illustrates getting the practices and processes that are really going to save you a lot of money up the front. So you've got the likes of pair programming there, continuous integration, TDD, and model storming, which we generally do, like in our test condition workshop and that sort of thing. And then what we're seeing here is like traditional acceptance testing, system testing, and that. Even reviews, code reviews down here, it's starting to creep up the cost of change curve. So basically, the longer you leave your defects in the system before you discover them, the more expensive it's going to be to fix. So pair programming is one thing that can be tricky to convince the executives and basically managers above the team that it's actually cost effective, because you've got two people sitting at the workstation, right? It's 2 times the salary. But what it's actually doing, if we see here again, pair programming's basically first on the curve. So one guy's hammering out code, and the other guy's basically pointing out the defects as soon as they're going into the code. So they don't get, they don't go up the cost of change curve whatsoever. They're being found immediately. Maybe I should throw these notes away. Just wing it. So test-driven development. This is all about creating solid code, right? It's not about testing. I'm probably guessing most of us here are sort of pretty much in the same boat with this. I'm not sure how many of us are actually driving a development with tests. But essentially this is where some of our biggest wins are found. And you're probably familiar, or may not be, with the red-green refactor cycle. Is anyone here that's not familiar with it? Cool. Okay, so basically what we're doing in the this cycle here is So we've got our specifications, and we're converting our specifications into tests, and then we're running our tests. The tests fail, that's the green, and then we write the smallest amount of business logic that we can in order to get that test passing, and that's our green. And then we come back to the refactor cycle, which is basically extending those tests, adding more specifications into the mix, or creating new tests which incorporate the new specifications. And then we run that test again, and the test fails, and then we just continuously go through that loop. And of course we're doing that in the development stage. So we're baking our specifications into the development process, and our specifications become they're living specifications, right? So two of the most costly bugs in history to date are the OpenSSL Heartbleed and Apple's Go to Fail bugs. Mike Bland did a proof of concept on actually getting these tests. He did a proof of concept. His idea was that if these tests had have been if this code had been driven by tests, as in TDD, or even if it had have had tests wrapped around it at some stage, that these defects would have never happened. And he's got this proof of concept on Mike Bland's got this proof of concept on Martin Fowler's blog, and it's quite convincing. He's broken the two issues down and put tests around them, and it's pretty much infallible that if they had have had tests around them, that they never would have happened. So yeah, another bit of ammunition basically for why we should be driving our development with tests. So this is basically the test condition workshop. Not sure how many of us are doing this. It's often what good Scrum teams will use immediately before they pull a sprint backlog item into the work in progress. So you've got a bunch of developers. Actually, generally what happens is a developer will decide he wants to work on a particular sprint backlog item, and he'll pull it into a work in progress and basically pull the people that know the most about that specific piece of work that he wants to get done into just a session, a meeting, whatever you want to call it. And what they do is they work through, so they work out what their quality budget is, and how much they've basically got to spend, how much they've got to spend on getting quality baked into the product up front. And yeah, this quadrant is basically just a useful sort of diagram to basically pull into that session and work out whereabouts we're going to focus our energies, just to get us thinking basically. And then that group of developers will generally craft up a set of test conditions. These test conditions can also be added to your product backlog item while they're in the product backlog, and start to get added as well. So you've got the authorities on the piece of work. I'm creating these test conditions, and that's part of the test condition workshop. And the great thing about these is that once you've basically got them written down, you can convert them into automatable tests. So there's heaps of frameworks and that you can actually use for this. This example is just taken off Mocha Cakes. Oh, yeah, so this is just that's a wrapper that sits on top of Mocha, which is just a JavaScript test framework. So the idea is that you create these test conditions, and then as you're developing, you can actually get testers and that to put bindings behind these, and then they're basically ready for the developers to start writing their tests, and then start writing their business logic to satisfy those tests. And then basically everyone in the business can see when these are actually done or not, because there's a lot of different ways to actually display the output of these. Like you can have, generally your tests will turn green when it's passing, and they'll be red when they're failing, and orange or something like that when it's inconclusive. So that's all part of your test condition workshop, and as part of that you'll also be thinking about optimising your test effort, so that's cost versus value to the business, and you'll be thinking about things like if we look at the test triangle, we've got the biggest wins generally down the bottom in terms of the value that we'll get out of tests. So I've got our unit tests down there, which is generally the developer's bread and butter. We've got our integration tests, which are slightly more expensive, but cover a lot more. Sometimes even from the UI all the way through to the database. A bit more fragile, and the further we go up, generally they get more fragile and more costly to implement. But your one change I've seen over the last few years is that with your UI tests, your UI tests basically are being used for your user acceptance testing. They're actually becoming kind of cost effective again in a lot of cases, because they're running on a lot of different platforms. So we're testing on multiple devices, laptops, tablets, handhelds, and in many cases we're also testing multiple browser versions and that sort of thing. Depends on your domain and that. But actually automating those is actually becoming more cost effective now, because you're covering so many platforms. So where am I here? Coding standards. So based on your coding standards and guidelines, we should be reviewing all code written, and even in many cases code that's not written, like libraries that we're pulling into our solutions. That's one thing that often we're not thinking about. So we're using a lot of potentially untrusted code out there into our solutions. So even with known vulnerabilities, there's a lot of libraries out there that we're actually using that have known vulnerabilities, and we're not even reviewing those. So that's a place where exploits can hang out, and if people can work out what libraries you're using in your source code, which is often not that hard in some cases, especially if you're running web apps and that, everyone can see what's going over the wire. It can be a pretty good attack vector. Group reviews too versus one-on-one reviews. No matter how you do it, just review your code. You can use group reviews or you can use one-on-one reviews. Personally, I found that one-on reviews are a lot more effective, because your developer's code that you're trying to review, he or she is a lot more likely to show you everything. And in fact, generally if you're using source control, then you're going to see all his changes anyway, and you're going to be able to review everything, even the stuff he doesn't really want you to see. If you're in if you're in a group scenario, then there's generally not enough time to show all the code that the particular developer's written, so he's going to be showing you the stuff he wants you to see. He's also more likely to lose face or feel like he's losing face amongst his co-workers and that sort of thing. So my personal preference is one-on-one reviews. There's plenty of tools and that you can use for that as well, or you can just go the low barrier to entry and flick around emails, if you've got a pretty small team. Yeah, so I mean your coding standards and guidelines are basically about getting your small things established and agreed on so that you can move on to concentrate on the bigger wins. If you can't agree on the small things, then you'll never agree on the more complex topics. And I've got quite a good an example of why coding standards and conventions are actually as important as they are. I do quite a bit of work for different organisations and that, and I have a set of standards and conventions for each technology stack. And if I go into an organisation and they've already got a set of coding standards and conventions, that's all fine, we use theirs, but if they haven't, then I'll often end up pulling my own in. And recently that was the case. I pulled my own in, and we inherited an outsourced project, and it wasn't even compilable. We had to basically build up the directory structure and that again to get it into a working state. And so this had a bunch of web services, and they were running on IIS, and turns out that IIS won't run binaries from any other directory other than its bin directory. If you have directories nested below the bin directory and you put your binaries in there, they won't run. And my conventions, as part of one of the conventions that specified that that should be the layout that we use, we just use bin directories, and my co-worker decided to put them in a subdirectory, and I spent about 4 hours trying to work out what the problem was, why it wouldn't actually run. And so actually establishing and using your coding standards and conventions stops this sort of thing from happening. And often you'll move on and not even realise that why you agreed on a particular standard or convention, but it's not till these sorts of times that you realise, if we had have just done what the convention said, then we wouldn't have run into this issue. So it's just an illustration of why they're quite important. So designs don't spring fully formed directly from someone's brain. They evolve and improve through design reviews, informal discussions, writing and changing the code. Design's about trade-offs and priorities. It involves restrictions, and it's non-deterministic. So 3 groups of developers will design something completely different to solve the same problem. Design is a heuristic process. Sometimes techniques will work for one specific problem but won't work for all. It's a definition of done. This is an example of a definition of done that the development team I was Scrum Master of put together. And so you've got a bunch of developers in the team. Developer says, right, I've finished that user story, right? So he's done all the acceptance criteria on the user story, but is it actually done? So that's why we have a definition of done, right? So he's coded it. Has he committed it? Has he pushed it? Has the code been reviewed? Does it meet the acceptance criteria? Well, he thinks it does. But basically all these things up here are part of the definition of done. So that piece of work, that user story that he's pulled into the sprint, is not actually done until all these are satisfied. So everyone knows what done means. So yeah, if you don't have a definition of done, then there's confusion there, and you need to have one. So get the best people you can find and afford, and you'll end up using less of them. Don't make your selections based on who can be hired the fastest. Aim to hire the developers with the best habits and solid history of producing great code. Do they blog? If so, review it. Do they participate in open source development? If so, that's an excellent excellent opportunity to review their code, and you can tell a lot about a developer by reading his code, where his mind's at. So it's a fact that the productivity of individual programmers with similar levels of experience varies by a factor of at least 10 to 1, and teams are a factor of 2.5 to 1, or in other studies 3, 4, even 5 to 1. If you've got team members that don't work well with each other, work on getting them to improve. Yeah. If their attitude's just wrong and you can't change them, work on getting rid of them as fast as possible and try and learn from the mistake. So what do the most productive programmers look like? So we're looking at sustainable productivity. Professional developers will always trump your code monkeys. You've got to build a relationship with them in order to understand what makes them tick. It's always a good idea if you can actually have a relationship with the people that you're going to hire before you actually hire them. So yeah, that's why building communities and getting to know the people you're going to be hiring at some stage is a really good idea. So these professional developers, they're going to leave the code base in a better state than they found it. They're going to raise alarm bells when they see technical debt getting out of control. They're conscious of how readable and maintainable their code is. And they'll be driving designs with unit tests, aka TDD. And code added on top of CodeMonkey's code often starts to exhibit hard to track and replicate bugs. And these are the sort of things that we often don't think about when we're hiring a developer. So you've really got to get inside their heads. I know Ed talked a little bit about co-located teams and that yesterday. But there's another take on that as well, and distributed teams allow us to obtain the best talent no matter where it is. And developers can set up their own office space and they can have it quiet, they can have lots of light, they can have the right machines, they can have everything basically just perfect for hyper productivity. But we've still got the issue of communicating, right? Communicating from my place to the client's place and amongst all the team members. And I think what Ed was saying with the 180-day rule is bang on. You've got to keep those face-to-faces, like the physical face-to-faces up. But there are tools that go a very long way to actually to getting there. And I'm talking like tools like push-to-talk, because I've worked in a few distributed teams and we've had really good success. I mean, yeah, you've got to get the empathy levels up and that sort of thing. That's why you do need the face-to-faces. But tools like a Mumble for push-to-talk, I've used, and it's been excellent. It's been really good for verbal. Like you can just be walking away and you just hit a key and you can talk to the team. And Squiggle's another really good one. So basically what that gives you, it's low bandwidth. You'll get a window and you can see all the developers' faces or wherever their webcam is pointing. So you get still snapshots taken every, I don't know, I think it's 10 or 15 seconds or something like that. And so you can just click on those images and pull them into a group discussion, or you can click on one and have instant messenger. You can have voice only or voice and image moving pictures as well. So in some cases it's actually better than being co-located because you get your quietness, and it's just a little bit more effort to actually try and communicate with someone than just to go bah, 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 just to lean over your shoulder and talk to them. Oh, back up. We've also got with diagramming, we've got Google Draw, we've got Draw.io, and there's loads of other tools, online drawing editors that the rest of my team can be working on at the same time I'm working on. We're all in different locations. online code editors. We've got things like Hackpad, Firepad, JS Fiddle, and yeah, lots of others. IDEs, we've got Cloud9, CodePen, Codio, REPL, there's loads of them. So there's no excuse not to be using them. So yeah, this pretty much comes back to getting the best talent in your team, making sure you've got the best talent, and it's debatable whether, my perspective is that it's debatable whether co-location should rule out the fact for getting the best developers. Personally, I'm sort of erring on the side of hiring the best developers no matter where they are, and your productivity will be high because they will use the correct tools, they will communicate, and they'll do all the processes and practices that need to be done in order to get stuff out the door. Version control, let's just make sure we're using it. Work item tracking, we've got, so Scrum gives us the product backlog and the sprint backlog. User stories as product backlog items. Very excellent for promoting discussion, which fleshes out the details, and used to spawn test conditions where the details live. So a wiki, use a good one. Use best of breed wiki, otherwise you'll get people that won't want to use it. Yeah, so there's two different, well, there's a few different skill sets there, right? There's developers, and then there's like your executives, which are not that technical. So find a wiki that works for everyone, and my personal preference is Atlassian's Confluence. I've introduced that to a few clients, and pretty much everyone in the organisation uses it and loves it, and everyone's contributing to it. It works. Build system, continuous integration, running your unit tests, and nightly build, running your longer running tests. So these are my monitors at home. These are 2560 by 1440 pixel LEDs. So why does screen real estate matter? It's like developers will have often 40 windows plus open that they're working on. So they'll have multiple code editors, text editors, just loads of applications running, and it can take sort of like half an hour, 45 minutes, an hour plus to get a complex hierarchy into a developer's head. So he's working away on that, and then he's got to, the developers have got to constantly switch windows to specifications, back to the code, back to all sorts of other things. And the shorter we can get those switches, the less likely the pictures, the code hierarchies and that they build up in their head are likely to fall out. So if we can make those context switches as fast as possible, then it's a productivity bonus. And having big screens, big real estate really does help that. Machine speed is probably becoming less of an issue now because fast processors are they're doing everything we need to. I think I/O is still a little bit of a bottleneck, but then solid state drives are sort of coming to the party there. But just make sure your developers have got the best hardware best hardware available, basically. Desk seating arrangement. So you want to get your developers to get lots done. They're going to spend a lot of time sitting in a chair. You want to keep them there, right? You want to keep them focused. So buy good chairs. This is actually this is a picture of the chair that I sit in at home. I can sit in that for 8 to 10 hours and still not even really realising realise that I'm sitting in a chair. So you don't have all the aches and struggles and that, and it just allows you to focus on the job that you want to get done. Stand-up desks can be also good for some devs. So let them decide what they want to use and also how to decorate and fit out their offices. So again, you must have CI running, even starting small, getting it to build your code and then worrying about Git hooks and that sort of thing later. So, or Git, source control hooks. Yeah, so hooks are good for things like, so I'm about to commit some code and I want the test suite, the unit test suite, fast running tests run over that code before it's committed. So I issue a commit command, and so you've got a pre-commit hook there that actually runs your tests without the developers having to think about it. So there's basically no way they can get around running those tests. So your source control, when it's committed, it's passing all tests. There's no way they can get around that. So that's what pre-commit, or any commit, there's pre-commit, post-commit, and all sorts of other hooks that you can use on the best breed source control systems like Mercurial and Git. Also, make sure it's obvious to the team when your build's broken. Even consider reporting on broken builds, and potentially shaming developers if the duration that the build stays broken for is longer than the agreed on duration, and add that time to the definition of done or automate it. So if continuous deployment fits your organisation's process, use it, or at least be able to deploy at the push of a button or a run of a command line. So we produce working software as a Scrum team every iteration, every sprint, and to sustain that for years, which we should be able to do if we're running Scrum. You must be investing in quality up front. So the team can produce software really fast. The Scrum team can produce software really fast. It can also get the code base into a mess really fast. So just be careful not to let your developers go unthrottled and unchecked. Make sure there's actually something in place to get these checks in. So these fast running tests are the tests that sit at the bottom of your test triangle. And so slow running tests create frustration and kill developer productivity. So it's worth measuring these and rewarding developers for creating fast running tests. So potentially let your team work out how they can do that. At a threshold to keep under to your definition of done for cyclomatic complexity. That's just the complexity in your code, because that's one of the biggest things that developers should be concerned about is managing complexity. Once it gets out of hand, it's really hard to pull it back in line again. And test-driven development helps a lot with that, because it decouples your code and basically produces code that can stand on its own independently. If it's testable code, then it's reducing your complexity. And your static code analysis tools, consider basically running those on a pre-commit hook. Again, it's getting the simple things right so that we don't have to keep thinking about them. We can think about the more complex topics and things that are more important for us. So executable specifications continue to be useful even after the initial release. They're our living specifications that by definition is always going to be up to date, because if it's not, then your tests are failing. So talking about how to get these ideas accepted into the organisation that you're working in. So tailor the message to suit these needs, and make sure you understand why the existing processes exist. A lot of the business's convoluted processes are actually birthed out of a need rather than just politics. And with relationships, put yourself in the shoes and understand the perspective of the person you're trying to sell the idea to. Make sure you're giving empathy. convincing the people with credentials will give your idea more clout, and make sure you develop an attitude of gentleness. And if it's a struggle to establish yourself as an expert, then enlist other experts to carry your idea forward. And do you have the people's respect? Have you served your time? Have you done the hard yards? And as most of us probably know, Nelson Mandela is a pretty good example of this. So he did the hard yards, did 27 years in prison for something that he didn't do, and that became his authority to solve a major problem in his country. So he was an expert, and had respect because of it. And if the decision makers know the expert, then it's all the better. So this is basically about building them up, and not only to their faces but also behind their backs, because the things we say behind people's backs, especially in organisations, from my experience, and probably everyone here, tend to come back to the people that you're talking about. So make sure those things are good things. And talking with managers in private and communicating on their level rather than your own, and leading the decision maker to the discovery of your idea rather than pushing it on them or forcing it on them. And so that's his aha moment, when he actually gets it, and if he works out the solution by way of what he thinks is his own, then he's a lot more likely to run with it. So rather than telling him the solution, lead him to it. And also, attention spans are a lot longer in private than they are in group settings. Your worst enemy can be your greatest ally. Be open to resistance, and opposition will find all the faults in your ideas. So leverage that to improve your ideas. And people will also realise that you're looking at all aspects and all angles of the idea, and are going to be more likely to accept it if you are shown to be accepting negative criticism. Often we think that if we have an idea that we're sure is better than the existing way of doing things, then people will, and can logically explain it, then people will accept it. But most of the time that's not the case. People base their decisions on their emotions and then back them up with facts. The studies have shown that motivation has a larger effect on productivity and quality than any other factor. So managers lead from the front, walk the talk. So what can we do to make this project go faster? Do you need more engineers? Throwing more engineers at a problem usually makes the problem worse. The only definite way to get something built faster is to build a smaller thing. Noise everywhere kills deep thought. Allow your developers to create a space that they love to work in. And when I've found myself that when I work from home, my days are generally a lot more productive than when I'm working for a client in a noisy office with developers all around me, and well, not just developers but everyone, and there's just noise and chaos everywhere, basically, interruptions all the time. So content, the content of the message is only 7% in communication. The rest is voice, tone, body language and context. So email's not very effective, it's about 7%. And it takes a lot longer to craft an email than just to open your mouth and talk. And with meetings, just make sure that you're calling meetings at the most unproductive time for a developer. Work out what those times are. Often first thing in the morning, late at night, sometimes at lunch. Just be careful that You want to have the developers' most productive times uninterrupted. So yeah, context switching is another big productivity killer. So how do we work out how much context switching we're having and how it's killing us? So you're going to need to provide metrics, track ad hoc requests and interruptions. So in a previous Scrum team that I was working in, the team decided they were going to add every interruption onto the sprint backlog. Onto the burn down chart. So whenever they were interrupted, they wrote down who interrupted them, what time it was, and the duration. And then in the sprint retrospective, they discussed why that interruption happened and ways that they could stop it happening in the following sprints. So the best way to motivate developers is to let them develop. Provide an environment to stimulate focus. And the work itself, freedom and expectation to exercise a variety of skills and T-shaped developers. So that's developers with a broad range of skills and a number of deep specialities, and try to get each developer on your team with a different set of deep specialities so they all complement each other. So people who tighten nuts on aeroplanes are generally going to feel that their work's more important than those who tighten nuts on decorative mirrors. So developers, like all of us, I think, must experience meaning in our work. People care more about the work that they can complete, whole and identifiable pieces of work, aka user stories. And knowing the results of their work and how they affect other people. Control over what and how they perform their work, and that's basically your self-managing teams. So many managers still need to realise that they can be freed up from a lot of work if they'll just let the development team manage their own destiny. And people work harder to achieve their own goals than someone else's. The team decides how much it wants to tackle, and each developer decides what to tackle. That's like basically when they pull in the sprint backlog items into work in progress. And the schedules developers create for themselves are always ambitious. So yeah, you don't need to manage them. Basically let them manage themselves. Setting objectives for developers works, but only pick one or two. More than that, and developers tend to lose focus. Developers don't respond well to objectives that change daily or are collectively impossible to meet. So half of what a developer knows in order to do his job today is going to be unneeded in 3 years' time. And if not moving forward in the industry, then you're moving backwards. And developers are very motivated by learning new things. So let the developers decide how they want to grow professionally. And what we generally find is that organisations that are known for fostering personal growth attract the top talent. So just keep that in mind. And yeah, top developers like to invest a lot into their own time, experimenting, researching, teaching others, running events and that sort of thing. Let them do that, give them the time to do it, send them home at the end of the day, make sure they go home. Top developers love passing on their knowledge. This is part of what drives them and gives them their own identity. and consider assigning each team member to be a technical lead and possibly a mentor for a particular domain, technology or process. Again, this basically makes the each developer gives them identity basically. Yeah, so that's pretty much me actually, Alan. I've got a bunch of recommended reading here. The Fearless Change and Nonviolent Communication are a couple of books that I found really good for getting acceptance of your ideas into organisations that you work for. I think if you pick up a copy of each of these, and as soon as you start reading them, you'll think, this stuff's such common sense, but we're not doing it. So I'd recommend getting copies of those two books. And basically I've got a post on my blog on culture in the workplace as well, which is pretty good. And my blog, it's got loads of stuff on it, so check it out. Obviously these slides are going to be available somewhere afterwards. So those are actually links, those hard to read ones. So check them out. And Steve McConnell's Rapid Development and Code Complete. I took quite a bit from that in this talk as well. So that's pretty much me. Any questions?
Okay, thanks Kim for getting through, showing true agile capabilities and inspecting and adapting when we had a technical issue with the presentation. But yeah, some really interesting stuff there. Good work. Any questions, guys? There's got to be one. Come on, we've got 2 more sessions left today. We've got morning tea, afternoon tea. No, but if you join me in thanking Kim for his presentation. Thank you, guys.